Next piece of our journey into sequences and series is looking at the geometric series. So in the previous video, we looked at the geometric rule for sequences. U1 times r to the n minus 1. And it's a very quick, nice way to write a rule for something that's geometric. That is something that has a common ratio. Just like with arithmetic series, we have a nice rule to find the sum of a geometric series. We don't actually have to add up all the terms. It can be very inefficient. We have two forms for the s sub n, sum of the first n terms. U1 times 1 minus r to the n over 1 minus r, or equivalently, notice that these are just, the order is reversed. R to the n minus 1, r minus 1. All that's been done, if you want to know how these are equal, factor a negative 1 out of the top and the bottom here. So we get u1 times negative 1 r to the n minus 1 over negative 1 times r minus 1. The negative 1's cross out, and I'm left with this. Now, why do we have two forms that are so very close to be the same? Well, for some people like one over the other. For others, they'll notice that if r is negative, this first one's nicer because it's 1 minus negative r. So then we're dividing by a positive number. If r is positive, then r minus 1 will be a positive number. So it really depends on the problem that you're dealing with. Depends on which one you like more. Do you like having two options? Does it really matter to you to not have to divide by a negative? It's really up to you. They're equivalent, and they're really not a whole lot different. The only thing is, it can sometimes help you avoid negatives depending on which you use. So here we go. Find the exact value of the sum of the first 6 terms of the geometric sequence. So we're finding S6. And since it's a geometric sequence, I know that I can use A1 times 1 minus r to the n over 1 minus r. Again, it doesn't matter which form of this rule we use. Now, one nice thing about the arithmetic or the geometric rule over the arithmetic one for sums is I don't need to know the last term. I don't need a sub n. I need the first term, I need the common ratio, and I need the number of terms. So first term is 8. 1 minus r to the n, so 1 minus 1/2 to the 8th over 1 minus 1/2. So this is where we now turn to our calculator a lot of times. And I put an 8 here instead of a 6. It's the first 6 terms. Hopefully you all caught that. And this is mostly going to be something that we go to the calculator, we plug the numbers in, and we crank out an answer because the numbers get so big so fast and so small so fast. I am going to do this without a calculator just for fun because it really is a good time. I'm going to do 8 times 1 minus 1 over 64. 1/2 to the 6 is 1/64 over 1/2. Now 8 divided by 1/2, that's 16, times 63 over 64. 64 over 64 minus 1 over 64 is 63 over 64. That's over 1. Okay, so these reduce 16 over 64. That's 1/4. 16 divided by 64. So my final sum exactly is 63 over 4. Now, if we're going to use the calculator, nothing wrong with that. I just decided not to. Let me get a calculator page going here. We're going to do 8 parentheses 1 minus 1/2 raised to the 6th power. And I always like to push enter at this point to make sure I don't make a mistake right in this next part, because I want to divide by, that's my numerator, I want to divide by 1 minus 1/2. And guys, you got to put this entire denominator in parentheses. Without the parentheses, we divide by 1 and then subtract 1/2. And well, that's just very, very wrong. So 63 over 4. Now, if I wanted a decimal equivalent of that, remember, so I've got this. All I need to do is put a decimal any place in this problem, and it returns a decimal. Personally, I'd rather have a fraction. So I'm not going to put that decimal in unless I have to approximate. And there we go. We're done. 63 over 4 is the sum of the first 6 terms. How many terms are needed for this sum to exceed 100,000? Oh boy, this seems really hard. So S sub something, S sub n, I don't know how many terms it's going to be. So let's start putting in the numbers I know. It's geometric. R is going to be 6 divided by 3. R is 2, that's cool. First term is 3. 3 times 1 minus 2 to the n over 1 minus 2. Now here's an instance where it might make a little more sense to reverse the order of these. So it's 2 to the n minus 1 over 2 minus 1. Doesn't really matter again. And I want to know, when is this going to be greater than 100,000? Woo! It's a big number. So we need to solve. So 2 minus 1, that's 1. That's kind of nice. I'm going to divide by 3. So 2 to the n minus 1 greater than 100,000 divided by 3. And I'm going to finish this thing out algebraically. I'm adding 1. 2 to the n. And just to simplify things, I'm going to change this to equals 2. I'm going to find out how many terms it takes to equal 100,000. So 2 to the n is 100,000 over 3 plus 1. Now remember, guys, how do we solve for something that's in the exponent? We use a logarithm. Log base 2 of 100,000 over 3 plus 1. Now I keep writing 100,000 over 3 because I know that 100,000 doesn't divide by 3 nicely. So this equals n. Let's go to our calculator and see what that gives us. Log base 2 of 100,000 divided by 3 plus 1. And I get 15.02. So n equals 15.02. And for the 15th term, I'm still going to be smaller than 100,000. So I need 16 terms. I have to round up. I need more than 15 terms to get to 100,000. So there we have it. There's the number of terms that we need. This formula is very, very methodical, and we plug in the stuff that we know, and we crank out an answer. And that's where I leave you for today, and we will pick up with some very crazy, funky stuff in the next video.